Hi, I'm Milan Morgenstern. I'm a PhD student here at Stanford GSB, and today I want to talk to you about a project I've been working on jointly with Kostas Vimpikis and Anila Savan, which is called the welfare effects of data tracking. So we're interested in settings where firms have technologies that enable them to gather consumer data and use this information to make decisions. In particular, we are interested in understanding the welfare implications of firms having access to such technologies in different markets with different structures, and also understanding different aspects of these markets, like what happens with prices, what happens with firms' profit, depending on what technologies they have access to. Something very specific that we're interested in is understanding how does this all depend on the consumer's knowledge of what firms can do with their data. What do I mean by this? I mean that it's very different to live in a world with consumers that have developed privacy concerns and maybe wary of sharing information with firms because I think this will lead to a negative outcome in the future versus a world where consumers maybe do not understand how their actions generate data or just don't think that much into the future, so they don't develop these privacy concerns. And in particular, we're interested in a context where firms sell various products, and the transactions from that result from the activity of one product generate information about customers that is valuable for the firm to make decisions regarding another product. So to give you an example, think about the banks or the financial industry. So when banks compete to attract customers first they compete to attract customers to offer them loans. And once a customer has chosen a bank to apply for a loan, the application for a loan is very detailed. So it gives the bank a lot of information about the consumer, the credit score, where does the applicant lives, what is their net worth, and the other various features about the customer that gives a very detailed picture in some cases. And this information can later be used by the banks to offer these applicants some other products, maybe credit cards where the interest rate is specific to each customer, or different types of products that can be personalized based on this information. So this is one example. There has been some literature that touches related issues to what I'm describing, and I'll skip this for the sake of time, but here is a list of very good papers that consider related issues. So let me jump straight into the model. We're going to consider an economy with two products and two firms, where the competition structure is illustrated in this diagram here. Both firms compete to sell product one, and then one of the firms, firm B in this case, is a monopolist for the selling product two. It's the only firm that sells product two. We're going to assume no production cost for both products. And we're going to assume that firms sell horizontally differentiated variants of product one. And to model this, we will take the hoteling approach, where we put firms to be located in the extremes of the unit interval, and then consumers, as we will see, will have some location that denotes the relative preference for one firm or another. So consumers will be heterogeneous. We have different types, and their types is a two-dimensional vector, which we denote by alpha and theta, which we will assume is uniformly distributed in the unit square. Now, alpha will denote the consumer's valuation, the consumer's location in the hoteling line for product one, and then theta will give us the valuation for the consumer's valuation for product two. And we have this parameter m that will scale these valuations up or down. And we will interpret these parameters, as we will see later, as the relative value of data. So for high values of m, the valuations for product two will be distributed in a wide range. So there is potentially more benefits to learn these valuations from consumers. Okay. And we will normalize the transportation cost, the unit transportation cost in the first market to 1/2. Now, we will have this as a sequential game with incomplete information. So let me tell you about the timeline that we are considering in this case. Let me put my video here. So first, firm will set the prices for product one, both firms. And then the consumer will see these prices and choose to buy from either of these firms or not. Okay. Now, here is where the data tracking comes into place. We will have that if the consumer buys product one from firm B, so from the firm that sells both products, this will reveal her type to firm B. Okay, so the way firm B gathers data in our model is by selling product one to the consumer. So in this case, we intuitively interpret that, after selling product one for some type of consumer, firm B can learn enough about their purchase history and their behavior pattern to have enough information that allows firm B to learn the valuation for some other product. Okay. Now, this can be, of course, an extreme assumption. In some cases, the firm will not have the technology to really learn the exact value of data. So we're thinking of settings where firms have a substantial data processing capabilities to really learn something valuable about the consumers. And for example, in the case I was describing at the beginning about the banks selling loans, well, the loan application really gives a lot of information about the consumer, not just a couple of data points. Okay. On the other hand, if the consumer does not buy product one from firm B, then in this case, firm B will update its belief on the consumer's valuations. And then after any of these instances, with the information firm 2 has available, it will set the price for product 2. Right? In one case, it has perfect information about the consumer's valuation. In the other one, it has some belief that some distribution that represents its belief. And after this price is set, the consumer will observe the price and decide whether to buy or not, and pay off or realize. Okay. So we will analyze 3 variants of this game, 3 settings, and compare the resulting equilibrium outcomes. The first setting, which we call it a restricted setting, you can think of it as if a regulator came and just prohibited firm B from having these data tracking capabilities. So effectively, this would stop the flow of data from that is generated from the transactions in the first period to make decisions in the second period. Okay. Now, without this regulation, so when firm B has its data tracking capability, the outcome will depend on whether consumers are aware of these capabilities or not. So we will consider 2 scenarios, 2 settings that differ on the degree of consumer sophistication. First, we consider naive consumers. By this, we mean consumers that when deciding from which firm to buy product one, when they make this decision, they do not incorporate the future consequences that buying from either firm brings in the second period. Whereas forward-looking consumers do incorporate these future consequences in their decisions in the first period. Okay. And we will characterize the perfect Bayesian equilibrium for these three settings, and then compare the resulting outcomes. Okay. So let me move to the restricted setting. So as I mentioned, in this setting, firm B has no data tracking capabilities, and this effectively splits the game into independent games. One for the competition game in the first period, and then a simple monopoly pricing problem in the second period. So and moreover, it makes the first market be symmetric for both firms. So both firms are exactly have the same incentives in the first market. They set the same price, and the market is split 50-50. So consumers the consumers that have a location closer to firm B buy from firm B, and vice versa for firm A. And then in the second period, since there is no flow of information from the first to the second period, firm B's belief on the distribution of consumers' valuation will still be a uniform distribution, as we assumed with the prior distribution. And therefore, the price it sets for all consumers is M/2, which is a monopoly price for the distributions. And then half the consumers, those with high valuations, will buy the product. Okay. Now let me consider naive consumers. So now in this setting, firm B has data tracking capability, so it will learn the type of the consumers that buy product one from it. But consumers act as if this wasn't the case. So they, in the first period, when buying product one, they just see the prices in product one and their location and make their decision based on that, without understanding the implications of revealing their type to firm B if they choose to buy from it. So what happens in this setting is that we have price dispersion, with firm B setting a lower price than firm A, because firm B has an incentive to capture a larger portion of the market to learn the type of more consumers. And then effectively gives a discount in the first period, but it recovers this investment in the second period when it has full knowledge about the consumer's valuation, and it can set personalized prices and extract essentially all the surplus from these consumers. So this price dispersion implies that the firm B's share of market one is more than 50%. As we can see in the picture now, the top square that represents the consumers that buy from firm B in the first period is larger than the one in the restricted setting. And then in the second period, now for consumers, as I mentioned, that for consumers that the firm B now knows their type, it will set a personalized price equal to their valuation and extract all the surplus from them. But for the other consumers, the belief on of firm B's belief on the valuations for product B will still be a uniform distribution. Why? Because the decisions across periods are independent for the consumer. So when we do the Bayesian updating, it will give us a uniform distribution, and it will give us essentially the prior distribution, which is a uniform in this case. And the price for what I'm calling here new customers, so customers that bought product 1 from firm A, will be M over 2, as in the restricted setting. The same monopoly price, and then only consumers within the subset, only consumers with high values of theta will buy the product. Okay, so fixing this picture, what happens now if consumers become forward-looking? So they now incorporate future consequences into their decision in the first period. So think of a consumer like the red dot here. So someone that is close to being indifferent between buying from either product 1 from either firm, but has a high valuation for product 2, which is because it has a high value of theta. So now it says, okay, I'm very close, I'm almost indifferent between buying product 1 from either of this firm, but I know if I buy from firm A instead of firm B, I will not reveal my type. All right, if I buy from firm B will know my valuation for the next product, and I know it will set a personalized price equal to my valuation, so I will lose all the surplus in the second period. So I'm willing to, do a little with worse of today to make up tomorrow and have a higher utility tomorrow. And then this induces a shape of a curve that splits the consumer type space, and that is this piecewise linear function, right? So now consumers with higher values of theta are relatively more likely to buy from firm 1 in the first period. So now that firm B realizes this, it says, okay, now wait, consumers with high valuations are trying to hide from me. Then when for these consumers, when the belief updating is done, the resulting distribution will be skewed towards high values of theta, and therefore the price that it will set to these consumers on the second for the second product will not be M over 2 anymore, which was with the uniform distribution. It will be a higher price. So this M times theta star that we have here, that is higher than 1/2. So we end up having this kind of shape. So just to summarize, with forward-looking consumers, we have with a split in of the decision of the consumers according to their decisions for product 1, as following the shape here in the right that I just described. And more importantly, we have larger price dispersion than we had with the naive in the naive setting. Why? Because now not only firm B has the incentive to lower the price to induce more consumers to buy from it, but also now that consumers realize the value of their information, they need a stronger discount or a larger discount to be induced to come and buy from firm B. So this induces larger price dispersion. And then in the second market, as I discussed before, we have a price for the consumers that bought from firm A in the first period, we will have a price that is higher than M over 2. And we get the split of the consumer's type in this form. So finally, I'll discuss the comparisons of welfare outcomes across the 3 scenarios. First, let me start with consumer surplus. And the surprising result here is that consumer surplus is lowest in the restricted setting. So why do I say surprising? I'm saying that consumers are better off when firm B has data tracking abilities, even if consumers are naive. Okay? The fact that the forward-looking setting is better for consumers than the naive setting shouldn't be surprising. But what I think is surprising is that the naive setting is better in terms of consumer surplus than the restricted setting. So what is the intuition driving this? Well, So as we saw, firm B has incentives to lower prices for product 1 in order to acquire data from consumer to learn the consumer types. And all consumers enjoy these lower prices. And then when we compare the restricted and the naive settings, some consumers, instead of having the monopoly price, are charged a personalized price. And some consumers are worse off, but when we take into account these two effects, it turns out that in the interior equilibrium we just described, the first effect dominates. So going back to the regulation point of view that I was discussing, we're saying that regulation that removes data tracking can reduce consumer surplus, even with naive consumers. And the result here is driven by competition, because we have these lower prices in the first market. Indeed, if firm B were a monopoly in both markets, naive consumers would be worse off when the firm has the data tracking abilities, and this is in line with what other papers have shown. But what we're showing here is that with competition, this can be different. Now, for firm B's profit, the interesting part is that firm B is better off always with data tracking abilities. So regulation is always harmful for firm B, even if consumers are forward-looking. So there have been other models where this is not the case, where having forward-looking consumers can give incentives to firm B to self-regulate and avoid using data from to do some personalization. In our model, we find that this is not the case. Firm B is always better off with data tracking abilities. And now firm A's case is also interesting. Well, firm A is always better off when in the restricted setting, when firm B has no data tracking abilities. But the interesting comparison is between having forward-looking and naive consumers. So as we can see in the chart in the left, firm A's profits will be higher with forward-looking consumers for small values of M, but the opposite will happen for large values of M. So why? Because we have these two conflicting effects. On one hand, what we call the privacy effect, that firm A can charge a premium to forward-looking consumers in order to avoid to have them avoid revealing their type to firm B. So in some sense, firm A is not only selling a product 1, but it's selling a product 1 plus not revealing your data to firm B. On the other hand, as M increases, firm B has incentives to compete more aggressively, as we saw, to acquire data. And this drives prices down and can drive them low enough so that the firm A is worse off with forward-looking than with naive consumers. Finally, I'll just leave some concluding thoughts here for those of you that want to read more, and thank you very much for your attention.